Hi everyone, this is Bellman food algorithm, which is useful to find shortest path from a single source. For example, if a given graph is like this, from source 0 to 1, which will be the shortest path? As per theoretically, we see like this one is the shortest path, and from 0 to 2, we have 4 here, and we have 1 minus 3. So if we come through this way, 1 plus minus 3 will be minus 2. So compared to 4, minus 2 will be less. So we can say this is the shortest path. Likewise for 3, 1 plus 2 is 3. If we can come through this way, 3 minus 3 is 0, 1. So 1. So theoretically, we can find like this. Using Bellman-Ford algorithm, how we can program, we'll explain. I'll explain to you all. So first, a Bellman-Ford algorithm, which will deal with negative number also. We have one more algorithm, Dijkstra, which is also leading with shortest path, but that won't accept the negative cycle. It can't find negative cycle, and also it will not uh, have the negative edge values. Okay. We'll see one more example which has a negative cycle. First, let us proceed with this one. So, for Bellman-Ford, we'll be initializing the distance area 0, infinity, infinity. So, uh, we have one rule called relaxation rule. Relaxation rule is if d of u plus c of uv is less than d of v. U is source node. So, for example, if you are taking 0, 1, then this is the C of U, cost of the U and V, which is also called weight or cost, anything we can refer. W or C, anything is fine. So, we'll compare, for example, here D of U is 0, weight is 1, 0 plus 1 is 1. In our array, distance of 1, D of V, 1 is actually infinity we have initialized. Since the found value is less than the infinity, we are replacing the array. It's like, okay. Uh, we'll replace that value within in this array. So for all the UVW values, we'll be maintaining this distance array. So in this note, actually, I've written 0 to 4 as a first example. So first of all, you from the graph, you write all the UVW values from like wherever the directed graph is there. You just write like 0 to 4, or 0, 1, 1, 1, 3, 2, for example. Where is this 1, 3, 2? From node 1 to 3, u is 1, v is 3, 2 is a w. Likewise 0, 1, 1, and like 1, 2, minus 3, 2, 3, 3. Write down all the possible UVWs. Once we have written all the UVW, we need to select one set. For example, we are considering 0 to 4. So when we calculate, our v is distance d of 2. So d of 2 we are getting 4 from this. 4 is less than infinity. Condition satisfied. Our relaxation rule condition is if d of u plus c of u comma v is less than d of 2, update it in the distance array. It is less than infinity, so we are updating here 0 to 4. Likewise, we will find d of v for all the UVW combination. Considering this one, we are getting d of 1 as 1, which is also less than infinity, so we are updating our array. And then 1, 3, 2 we are taking, 3 we are getting 3. And then we are taking 1, 2, 3. Now distance of 2 is minus 2. Previously we had 4, so minus 2 is less, so we are updating distance array. And another UVW we are taking, now we are getting 1, which is also less than 3, we are updating. So for the first iteration with all the UVW values we have done. Now we are going for the second iteration. In second iteration, it's like we are not getting any value which is greater than which is less than the current distance array. So if in some iteration, it's like if we have 4 nodes, right? We need to try n minus 1 iteration. That is 4 minus 1, 3 iteration. In a, if we are these values are changing even after third iteration, then that means it has a negative cycle. We can't find the shortest path. If in this case, in the second iteration itself, nothing is changed. So we can say like this is the shortest path, d of 0, 1, minus 2, 1. When we manually calculated no initially for 0, 0, 1, my 0, 1, 2 minus 1, na, our answer is 0, 1 minus 2, 1. So from source node 0 its self node. So 0, 0 to 1, we are saying 1 is the shortest path. From 0 to second node, we are saying minus 2 is the shortest path. We said now from 0 to 2, we actually have 4 one path and one more path. Compare it to 4, minus 2 is the shortest path. When we apply the Bellman fold also, we got this. So this is how we are using. I'll show you the program as well. We have one more problem, the second problem like this. So here we have the negative cycle, like the cycle is closing now. So um, here if we calculate the CVW and apply the relaxation rule, our distance array, this is like after first iteration and in the second iteration also every time it is getting updated. So after n minus 1 iteration, if distance gets updated, then it is a negative cycle, no shortest path will be available. And third iteration also we have tried, it is still updating. So the program will calculate like we'll get the number of vertices, number of edges, and then we need to enter all the UVW values. Um, and then once we got all the values, we are initializing the distances. First distance is 0 and another in max, which is infinity. And then relax rule we are applying. So if source node is not equal to infinity, dfb we initialize as infinity, but the source dfu should not be infinity to calculate this. And distance, so we are saying source of j plus weight is less than the distance of j, then we need to update the distance array with this value. Mm. Check for negative cycle. So here we are checking even after the n minus 1 iteration whether the value is getting changed. If so, we can print like it is a negative cycle. Once we calculated the distance array, we are just printing that array, the shortest path. Hope this will be helpful. Thank you. Difference between Digistra and this one, we can browse and understand. Main thing is Digistra will find negative cycle. Bellman Ford will find negative cycle. Digistra can't find the negative cycle. And Bellman Ford can work with the negative wedges. Digistra, it need all the positive wedges. Thank you.